Hello and welcome to EE233. I'm your instructor, Gregory Myers. In this series of videos, we're going to take a look at some of the core functionality that you will need to build for yourself using the C programming language. This is mainly going to focus around file input and output, string parsing, and sorting. This will be broken up into several videos, and in this one, we are just going to touch on the basics or on the structure that we're going to use moving forward. So to begin with, I would encourage you to take a look at my physics demo, particularly the example in which we broke out our hard work that we did in our physics driver. We put it into a separate physics.h or header file and a physics.c source file. We'll be using the same pattern here, and I've already provided you with a .c and a .h file. And if you notice now, I have my three files open. My core.h has some of the enums that we're going to be using, as well as some of the function signatures that we are going to be using. Additionally, my core.c already includes the stubbed in functions. Now, please note, this is only the starting point for this project, as we will be growing this considerably. The idea being is that your core.h is essentially going to be a dumping ground of sorts for functions that you will use in future projects and potentially in future courses as well. So to begin with, what I'd like to do is I'd like to play around with some strings, because that is going to be a primary focus of our project here, namely how to read and also to write to the file system, write strings, for instance, to a file, but also to be able to do things like compare and sort them. So we're going to be taking a look at multiple different aspects almost simultaneously here. So to begin with, what we're going to do is we're going to create some temporary variables with which to play around. They are going to be of type character. I'm going to just call them rather simply sample01. I'm going to make them both of size 10 here. So we have a sample01 and a sample02. Once again, don't focus too much on the names necessarily, but we're just going to play around with these. We're going to see how we can initialize strings and also the difference between a character vector and a string. So first and foremost, there's two ways in which you can initialize them. One is you can do it at the time that you declare it, in which case I'm just going to say sample01 then is equal to Gregory. You cannot, unfortunately, do that after the fact. So you cannot say something like sample02 is equal to Gregory, because essentially what you're doing there at that point, and if you try to compile, you'll see you'll get an error there. But effectively, what you're doing there is you're leveraging the pointer, okay, or the fact that a character vector essentially points to the first character's address. So in this case, you're going to get a compile error. So the second way then to initialize a string is going to be using the string copy function. And the string copy function specifies the destination first and then the source. So in this case, our destination is going to be sample_02, and the source is going to be Gregory. Now, when we compile this, you're going to see that we need to have our string.h included, because otherwise you're going to wind up with a warning. And so here we've successfully built two strings. What I'd like for us now to do is I'd like for us to go to our project. We want to right click on our project. We want to go to properties. We want to go to run. And we want to select the external terminal. And for right now, we're not going to use any switches, but we're going to hit apply and then OK. And I'd like for you then to put a breakpoint then on one of your lines here so that we can stop the execution of the program. So go ahead and put your breakpoint there, for instance, on line 22. At this point, then what we want to do is go ahead and debug our project. It's going to step into the first line of code that it can execute, and you should see the green arrow next to that red box there. And so if you come down here to your expression evaluator, if we were to type in sample underscore 01, you're going to see that it essentially has garbage in it. And likewise, sample 02 also has garbage in it. Instead, what we want to do is we want to step, and we're going to go ahead and step once more so that we are past both of our executable lines of code. We're actually down at the return statement. And so what we want to do is we want to take a look now at sample underscore 01. And what we can do, in addition to looking at the entire string, we can look at individual values within the string. So sample underscore 01 square bracket 0 is actually a capital letter G, which maps back to the ASCII value of 71. You can then also look at subsequent values. So there's the lowercase r, lowercase e, and you see next to that the numerical equivalent, or the ASCII numerical equivalent to each one of the letters in my name. And so we're going to continue with this. And now as you get closer to the end of my name, you'll see that the 7th character is Y. If we go then to the index equal to 7, or the 8th location, you will see now a different value. In other words, you're going to see something you probably didn't expect. Essentially what that is that's the string termination character. And so the \0 indicates end of string. So we're going to use this concept quite a bit moving forward, but what you want to recognize here, that a character vector is essentially a collection of characters. A string is a collection of characters with a special character on the end, that end of string or string termination character. And we see it not only in sample 01, but also if you come along, you'll see sample 02. Notice it's got some interesting junk left over there on the end. But if we come along to the 6th character, we'll index equal to 6, which should be the Y in my last name. There's 121. And then likewise, if we go to 7, then you'll see your end of string, 8, and then so on. And so the idea here is that we do still have to keep track of the number of characters in your vector and make sure that you leave enough room for that end of string character. So in other words, a vector or array with 10 characters, 10 characters long, can only store 9 usable pieces of information because it needs that end of string character. Now, let's just to reinforce this point, let's do something else here. I'm going to use my, I'm going to do it in both cases here. I'm going to spell out something too long, including spaces, and I'm going to see which one of these actually survives both my compile and my runtime. So we have something too long in both cases, and I'm going to go ahead and build it. And you're going to get a warning there because the array of characters is too long for the variable that you have allocated. And specifically now you'll see that it is warning me on line 22. All right. So once again, it's just a warning. So technically it could work, but we will go ahead and change this back to just something. And if you notice, something is going to be 4, 5, 6, 7, 8, 9 characters long. So it's going to leave just enough room for that end of string character. So if we build this one more time, you don't get a warning. So let's go ahead and debug this one more time. All right, we're going to step a couple of times. As a matter of fact, if you want to, you can go ahead and put a breakpoint on your return and then just simply hit continue. Nothing happens at runtime. Your system doesn't crash or anything along those lines. But if we come along now and we say sample underscore 01, you'll see that it says too long. Well, that's very strange. If I type in sample 02, I get something followed by a space. Well, what's happened here is if you take a look at the address of sample underscore 01, you'll see that it is F6, okay, which also corresponds then to the address of the first character in sample 01. Sample 02, if you'll notice, is EC. Now, in this particular case, it seems a little strange, but technically what's happened here is that sample 02 was placed in an earlier spot in memory. So what happened was when your string copy function attempted to copy a string that was too long into your sample 02, it didn't have enough room in sample 02 to store the end of string character. Instead, what it did is it kept writing the data past the end of the allocated space for sample 02, and it actually overwrote part of sample 01, which is why, if you take a look, once again, sample 01 has too long, and sample 02 has something followed by a space. So with that little piece of knowledge now, let's do a couple of other tests here. We know that this doesn't work out correctly, so let's go ahead and stop debugging. If anything, what we'll do is we'll focus just briefly on the sample 01 for this last demonstration in this video. And what I'd like to do now is I'd like to do two things. I'm going to create one more temporary variable. It's going to be n, and we're going to initialize n to 10. That's not coincidental. N is supposed to be the length of the sample 01. And I'd like to show you two different ways, or rather remind you of two different ways that we can enumerate through a vector. So the first way is going to be using a while loop. And so what we can say is while sample square brackets 01, and what we're going to use is we're going to use a temporary variable called index. So while sample underscore 01 square brackets index is not equal to my end of string character, what I'd like to do is I'd like to simply printf the character and the index. So I'm going to say something like sample underscore 01 square brackets index. Rather than have square brackets index, I'm going to say %d, and I'm going to display the value or the character at that location followed by a new line. And so in the first placeholder simply goes the variable index, and the second location goes sample underscore 01 square brackets index. Now to be able to make this work, I need to go ahead and create a temporary variable called index. I'm going to initialize it to 0. So it's going to be int index. And now what we want to do is we want to loop through using a while loop, looking for that end of string character. Now, that works if you have correctly initialized your string. In other words, that we left enough room for that end of string character. If you have not done so, a safer way to do that would be to check not only the value is not equal to the end of string character, but also that index is in fact less than the total number of elements. And then in both cases, what we want to do is we simply want to print out the value at that location. Now, the one thing I did forget to do in this earlier loop is we need to increment the index. Otherwise, we have created an infinite loop. Now, the third thing that I want to show you, or the third example that I want to show you, is just simply using a for loop. And so in this case is a third way rather to look through the elements in a string. We can simply say for index equals to 0, index less than n index plus plus. And in this case, what we would do is we would go ahead and print all the values in the string, even beyond the end of string character. So in other words, we would let n control the number of characters that we print. So the important thing to notice here is in this first example, I'm letting this end of string character drive the behavior of my while loop. In the second example, I'm using both the end of string character and as a safety measure, the index less than n. In the third example, I am printing out the contents of a character vector. So essentially what we want to do is let's put some notes here. I'm going to say treated as a character vector, followed by a new line. And up here, we're going to printf treated as a string. Okay, in other words, we're looking for that end of string. And then in this middle example right here, what we're doing is we're treating it as a string with a fallback plan, meaning that we're going to check to make sure that we don't run past our sample length. Now, let's go ahead and build this real quick to differentiate between these three examples. I'd like to do one more thing, and this is just mainly for aesthetics. I'm going to come in and I'm going to put one more new line here on the end. Once again, rather trivial. It's more for aesthetics. I'm going to go ahead and build this. I'm going to come out here to my command window. I'm going to change directories now to my newest demo, which is going to be my core demo. I'm going to go to my distribution folder, to my debug min.gw directory. And now what I'm going to do is I'm going to run my core demo.exe. And well, we have a little bit of a logic problem here. What did I make a mistake on? I did not reinitialize my index. If you're going to reuse your variables with a while loop, you've got to reinitialize your index, or you wind up with silly little things like that happening. All right, so one more time here, you'll see that in this case, I'm treating it as a string. I'm stopping at the what would be the 9th index because I do not print out that value. In the second example where I'm treating it as a string with a fallback plan, I still stop before that 9th value, or rather I stop at the 9th value because my not equal to null was violated, not equal to end of string was violated before my index less than n was violated. In the third example, I simply treat it as a character vector. In other words, I'm letting the n control the number of values that are printed out. Now, what I'd like to do for this example is I'd like to emphasize this flexibility here, this purpose behind this driver. We're going to be doing a number of different examples like this, and some of which are going to go into our core.c and our core.h. Some of these examples, though, are solely for the purpose of testing a particular concept, and this is a good example of this. So what I'd like to do is I'd like to create a separate function inside of my driver for each one of these examples here. So I'm going to come up here, I'm going to add one more function to my prototype. The return value isn't so important here, but we're going to go ahead and make it an int. And what I'm going to call this one now is string underscore demo. And it's going to be sort of a catch-all. Right now, I don't see much of a need to pass a set of input arguments. However, though, in the future, I might. So instead of doing void, what I'm going to do is I'm actually going to copy the function signature from main, and I'm going to pass then everything that would otherwise go into main into my string demo. And then from there, what I want to do is I want to just go ahead and go down here to the bottom. I've actually got a couple of functions already stubbed in here. I want to go ahead and create a string demo, stub it in, and I want to go ahead and return. You can either return 0 or simply exit underscore success. All right, and then what we'd like to do to sort of wrap up this particular video is I'm actually going to come along now. I'm going to cut all of the code that we just wrote, and I'm just simply going to paste it now into the string demo, which brings us now to then how are we going to call that string demo? Well, to do that, what we want to do is we want to be able to triage our switches, much like we did in the physics demo. And to do that, the first thing I want to do is I want to create another temporary variable. I'm going to call it index, and I'm going to make a quick reminder, a brief reminder of how our arguments work. And so I'm going to set up a for loop. I'm going to start off at index equal to 0, index less than argc, index plus plus. And inside this for loop, what I want to do is I just want to print out each one of my arguments. So argv, square brackets, and then for the placeholder, I want to use %d, and then the value of that argument is going to be %s. And in that first placeholder simply goes my index, and in that second placeholder goes argv, square brackets, index. And then the other thing that I want to do real briefly is up here at the top, printf, and I want to count I want to put out how many arguments I have. So in this case, argc colon square brackets n, and in that %d, simply print my argument count. Now, provided we don't have any mistakes in our code, if we build this, we should essentially have a very dumb executable that does nothing more than tells us how many arguments that have been passed. Now, once again, we emphasize this a little more in our physics demo. If you are uncomfortable with this, you should probably go back and take a look. What we're going to do now is we're going to jump straight into our arguments, okay, and how we're going to triage the arguments. And for this example, since we are going to be continuously building on this, I'm essentially going to use a very flexible or flat if structure. So the first thing I'm going to do is I'm going to check for my argc, and if my argc is equal to 2, that means that I have the executable itself as well as one additional argument. In this case, I'm going to check to see if my argc is equal to 2, and I'm going to use string compare I against argv square brackets 1 to see if it matches the switch that I ultimately want to use to call my string demo. Now, I'm not the most creative person in the world, so what I typically try to do is I simply use the name of the function with a slash in front. So in this particular case, I want to be able to call my string demo using a string demo switch. And if there is no differences between those two values, the argv square brackets 1 and my string demo, then what I want to do is I simply want to call my string demo function. I want to pass to it my argc and my argv, and that simply allows then the user to pass or whatever arguments they want ultimately to maybe a future and improved string demo. And then of course we have an else, and probably the best thing to do under the else is simply to make a call to your help function. Now we have built the prototype up here, but we did not actually do anything with it. So it's probably worth our time to come down here, probably before some of our sample functions, and just simply go ahead and stub in what will be our help. And just remember to update the usage as you go along. So in this case, it's going to be printf. I'm just going to go ahead and start us out here. So our first example is going to be using the name of the executable, which you can include, or you can simply focus on just the switches. In this case, I'm going to focus on just the switches. And we said that our first example is going to be string demo, so that now when someone runs this, with no arguments, we should get the help that tells them how to do it. And in this case now, if I run string underscore demo, I'll see the example that we saw earlier, except now it's been encapsulated inside of another function. Hopefully you found this video useful. As always, if you've got any questions or comments, don't hesitate to email me. And thank you for watching.